a lab coat, so you can tell I'm a scientist. So I have to preface this by saying that I am absolutely thrilled to be in front of you giving this talk because for literal years I have been using Alien as my media hook, my pop culture hook to explain what parasitoids are. So I'm at the American Museum of Natural History and my entire dissertation, which I'm defending next month, actually is, thank you. I'm very stressed out about it, but it's about parasites and how real-life parasites work. So I'm going to be drawing a bunch of comparisons between what is happening right under our noses every day in front of us with what you see in Alien, different mechanisms. So the next slide, if you were at the 1 p.m. screening of Alien in this very theater, it will be very familiar to you, but if you weren't and you weren't prepared, there will be a little bit of gore. And then on the other side of the screen, you're going to see the parasite that I study, that I work on the evolution and mechanisms of. So I'll explain why these work together or why they're parallel.
No, no, don't touch it! Don't touch it!
I'm glad that I could see your faces during that, because it was really fun. So just to clarify, to start off this talk, let's clarify what a parasite and a parasitoid are. A parasitoid is a kind of parasite, so it's kind of like the rectangle square kind of thing. But specifically one that has to kill its hosts for growth. So all parasites are parasites because they benefit at a host's expense, but a parasitoid specifically does so by killing its host after it's finished that developmental stage. From the last slide, you saw that the xenomorph has to burst out of a chest. So what do you think that makes it? It's a parasitoid. The insect that I study that was on the other side of the screen is actually a parasite, but I'll explain why I think the parallel is appropriate in a little bit near the end of this talk. So in light of the xenomorph being a parasitoid, the parallels I'm going to draw are mostly also parasitoids, and we're going to go with this life cycle as canon for the purposes of this talk. This is because in the course of doing research for this talk, I found out that there are a lot of opinions about what the xenomorph goes through in its life cycle, and that's mostly balanced around focused around the host attack larval stage and where the eggs come from, and that's because there are different theories that are presented and different kind of pieces of media taken as canon, different films that came out afterwards, but we will believe that the host attack larval stage is the same individual as the free living larva. It's not just a vehicle that deposits a new individual, it is the same individual, just different forms. So that's what we're going to go through. This figure actually came from this really fascinating article that came out very recently. You can scan this QR code if you want the PDF, and the parallel they draw most often in this article is between the xenomorph and the emerald cockroach wasp, or the jewel wasp, which you might have heard about because it's well known for zombifying cockroaches, and when it's kind of got this cockroach enthralled, it drags it to its nest, lays an egg in it, and then that egg does, at maturity, a chest bursting. So it's a good parallel, but I don't think it's the most appropriate because when the wasp bursts out of this hollow husk of a cockroach, it's already an adult. So I'll draw a more appropriate parallel in a second. These are the four main components of the xenomorph that I would like to discuss with you today, and we'll start with the first one. So as we saw, there is this chest-bursting event that has to occur in order for the xenomorph to complete its life cycle and development. And instead of the cockroach wasp, the thing I think is the most appropriate parallel to draw is Ichneumanoidea. So these are a clade, a superfamily. We're going to go through a lot of taxonomy today, of about 100,000 wasp species estimated. And these comprise two families, the two largest families in Hymenoptera, which is the bee, wasp, and ant order in insects, Braconidae, which are the top video, and Ichneumonidae, which are this bottom video. This is a very iconic wasp shape. They're really easy to identify because they've got that ovipositor, which she is using to drill into a tree in order to lay her egg in a larva that's in the bark. And then that larva will burst from that parasite at some point. The reason why I think they're a more appropriate parallel to draw is because from the top, you can see that these wasps can pupate outside of their host. So they're still going through another round of development before they become fully fledged adults, and that's what the xenomorph does in the movie. I would also like to take this moment to be an advocate for wasps, because as you can see, there are like 100,000 species. They're really, really diverse. A lot of people hate on wasps because you only know something like 5 or 3 species that you've maybe had a bad experience with in your life, but there are 450, maybe 1,000 species of wasps in the world, and only like a tiny clade of them sting. So they do a lot for us, and I'll come back to that at the end of the talk. So let's move on to the appearance of the xenomorph and the fact that they are predators as well as parasites. The parallel I would like to draw with this is Phronima. So this is a genus of plankton in the open sea. They have about 10 species, but that's because they're really hard to find, so it's probably very difficult to describe them. There might be more, we don't know. They parasitize other plankton, which are called salps. They're this barrel-like sea creature that are see-through, and because of their behavior of hollowing them out, laying their eggs inside, both sexes actually do this, but they don't lay eggs necessarily, the males. They're called the pram bug or the barrel amphipod because they look like they're in a barrel. They also predate upon a bunch of other species of plankton, and since they have so many limbs, apparently they have different strategies depending on what they're hunting. So if you were at the screening, you saw all those different deaths that the xenomorph expressed upon its victims, and the Phronima species do the same thing. There's also this rumor that is on the internet. If you search for Phronima and xenomorph, there's a bunch of articles that come up that the xenomorph was inspired by Phronima. So that's very fun. I can see the resemblance. Oh, so this is the other thing I want to talk about their appearance. Your brain on xenomorph. The second jaw, the inner jaw, is something that is very iconic. You can see it in a lot of different pieces of media that reference Alien. And when you search for that, like real life comparison, inner jaw, Alien, you'll find a lot of moray eel footage. And that's because moray eels have a pharyngeal jaw that they use to take food in once the first jaw has locked onto it. And that's because they can't use, they don't have the musculature needed to move food in after the jaw is clamped down. And they don't have gravity to just hork it down like otters do and things with outside of the water. This was taken at UC Davis, my alma mater, in 2007. But I don't think this is maybe the best comparison because, as you saw in the footage before, those jaws punch out. They can punch through metal, they punch through helmets, through skull, and I don't think the pharyngeal jaw can go past even halfway through the mouth. So instead, I'd like to propose an insect comparison in dragonflies. So these are odonate larvae, dragonflies and damselflies in the order Odonata, and they have a second set of jaws. Well, these are actually mouth parts, but they have a labial mask, the labrum, that shoots out and actually captures prey underwater. And I think that is a lot more punchy of a second jaw than the pharyngeal jaw and the moray eel. Dragonflies also have 2 penises, as a fun fact. And you can talk to my lab about that, those who study dragonflies, and my advisor, Dr. Jessica Ware. So now let's move on to phenotypic adaptability, or the ability that a xenomorph has to co-opt host traits from their tissue. This is kind of cheating because it moves past the first movie, but it's confirmed in the later movies by things like the predation, as you can see from the 2004 film Alien vs. Predator. I would like to bring up Ophiocordycipitaceae and Cordycipitaceae, which are 2 fungus families that are pretty diverse as far as we know, because every time a new host is discovered, that's essentially a new species. Oh, you probably know these because if you've heard of zombie ants a little while ago, but you can see that they infect way more than ants, and that fruiting body, the thing that appears to spread spores and can be very colorful, is very different depending on what host they're infecting. It's really, really cool. They're everywhere, including New York. So you can go into forests and maybe you'll find a fungus-infected insect. It also inspired the popular franchise The Last of Us, as you have heard, and I think it's like the most intriguing and biologically sound horror theory for how zombies can arise, perhaps. So lastly, let's talk about the fact that a xenomorph has those wildly different life stages, and now is my opportunity to turn this into a Strepsiptera talk. So this is what I study. The common name is the twisted wing parasite. Strepso and ptera mean twisted wing. And it's an insect order that's relatively small, but maybe bigger than we think, simply because every time we catch more, they're probably new species. And they infect things around the world, across many, many different hosts. But notably, they have different looking life stages. This bottom clip is the larvae coming out of a female's head in a mantis, and the top is a adult male mating with an adult female's head. So they're almost chest bursters, partially chest bursters, I would like to say, because the male you saw, an adult male emerging from the abdomen of a wasp at the start of this talk, but the female stays in the wasp forever, or the host insect. She just pokes her head out a little bit, and that she lives and dies within that host. So it's kind of wild. I'll explain the life cycle in a moment in more detail, but the thing that's most fun, I think, is that there's the family Xenidae or Xenidae, which is probably the best known since they infect wasps and are most visible. And they contain a lot of genera with the suffix xenos. Where have we heard that before? Sounds very familiar. It's from a Greek word that means stranger or foreigner, perhaps even alien. Wild. So drawing those parallel stages, the host attack larval stage in both life cycles are known to jump when they infect. There's this incubation that happens endoparasitically or internally as a parasitic lifestyle. And then, interestingly, Strepsipterans, I would argue, have this added layer of complexity because the males are chest bursters, but the females are not, so they diverge. And the females, I would kind of draw this analogy of like, if they were xenomorphs, it's as if Cain had gone through that chest bursting scene where it emerged just like its head a little bit, and then it stayed there. And then Cain stayed alive as well, so everyone was just kind of there. And I think that'd be really fun to see. The males also only live 4 to 6 hours, and there's this theory that the reason why the alien in the shuttle was not as quick and didn't kill Ripley like right away is because it was nearing the end of its life cycle, which is an interesting theory that I can ascribe to. So I study these organisms, and I've actually helped an adult female become a fully fledged chest burster because I needed her for her genome. I study DNA, and I needed to isolate her from her wasp host. So what you're seeing is Xenospeciae, a species that I collected in upstate New York. They are here. in your gardens, maybe, I don't know, and I'm pulling her head. This is the head of the adult female out of a wasp. The field of view is about 7 millimeters. So they're small, but they take up something like 60% of the abdomen. Sometimes they can be multiply parasitized, so there can be multiple parasites in the abdomen. And this is usually my hook for talks, so it actually went, it's fun seeing faces. It went viral last year, and it has something like 30 million views across platforms, which is nuts. But yeah, so we've gone through all of these, and that's an example of a multiply parasitized specimen. The most I've ever seen, that was 11 male pupae in one wasp, which is wild. But I hope that this has shown you this extreme biodiversity that we have, that art imitates life, and all of these mechanisms are real. We don't even need to go into space to find them. They're just occurring right now, every day. And even though Ash is a secondary antagonist, I would like to say that his words ring true, because they're really fun to vilify and hate and get disgusted at, but I'd like to argue that parasites should be appreciated for what just a miracle of evolution they are. Think about the chances that things like this could arise, the fact that there's so many intertwinings of complex life cycles that need to happen for these to exist in the first place at this number. And we ally with them all the time. So especially in agriculture, we use parasitoid wasps to protect our crops against things like pest caterpillars and other things that could potentially destroy entire cereal industries. So they balance out the world in ways that we'll probably never understand fully or appreciate. And luckily for us, they don't need our gratitude to keep doing that. So think about the little things sometimes. Just hold them in your heart. And with that, I'd like to thank you for being here. It's awesome to be here. And if you'd like more information or my contact info or more videos like this, you can scan the QR code from my website. Or if you want to become an entomologist and get into grad school for, I don't know, entomology perhaps, I have resources on this website. So feel free to pass them along, and I'll take any questions. Thank you.
To contribute something scientifically to another alien film, how would you relate it to science?
I think something that would be fascinating is the fact that there is it's a series or a movie, Alien Worlds, coming out soon. It would be really awesome so there's this phenomenon called super parasitism, and it's when a parasite becomes parasitized. I have no idea what would happen if Alien co-opted another parasite's traits, but that would just add like onion level layers. And I think it'd be awesome to speculate on. Yeah, thank you for the question. Something about like alien media in general that always kind of fascinates me is how limited we are by our own creativity and understanding of biology. So I'd love it also if an alien just completely defied what we expected. Because all of these, as you can see, are built on real life concepts. So they all have examples of how we think life exists. But yeah, that's awesome. Thank you for the question. Yes?
Did the filmmakers, when they made the original Alien movie, know all these species in mind when they were making the life cycle?
My belief is no. Because they knew about parasitoid wasps. There were a couple of interviews and articles that I was reading when they were questioned or talked about. But they did not know about like Phronima, for example. As far as we know, that was just a rumor that it was inspired by the appearance of the Xenomorph was inspired by Phronima. But they used, a crab species to make the facehugger. So in terms of appearance, there were a lot of species that were like scorpions for the tail. The acid blood was kind of out of pocket, but there were a lot of biological components, but not necessarily in the mechanisms. Thank you for the question.